Good morning. Here you can see the topic. Axioms, postulates, hypotheses, laws and theories. All are in plural form. Plural of hypothesis is hypothesis. So, very often, you come across with these terms in the study of science, in the study of mathematics, in the study of logical subjects. My channel is being viewed by science students, so I should say all the things which are related to science and mathematics, not the logical subjects. Okay? Science and mathematics. So very often we use these terms. In our textbooks, we see these terms: axioms, postulates, hypotheses, laws and theories. Question is, what is the differences between them? What is the differences among them? Okay. What are the differences? I know few students know this very well. They have clear idea about these terms. But what I have found in my teaching career is that most of the students are not well aware of these terms. Okay. In most of the cases, all the terms seem to be same for those students. That's why I have planned to make a video on this topic. Okay. Normally you won't find such topics in your YouTube channel, in any of the YouTube channels. Anyway, let's start. Okay. So, axioms and postulates. Axiom and postulate. Okay, singular form is axiom and postulate. Both are actually same. There is no difference between axiom and postulate, but a little difference is there. The term axiom is normally used in the study of logical subjects and mathematical subjects or mathematics. Okay, in the study of mathematics and logical subjects, the term axiom is used, and in the study of geometry and physics, the term postulate is used. So, what is the meaning of these terms? Both are same. If you use postulate instead of axiom, there is nothing wrong with this. Okay? You can use these two terms interchangeably. There will be no problem at all. That is not wrong. Okay? The first two terms, I am talking about now only the first two terms, axioms and postulates. So, what are those terms? What is the meaning? Meaning is that a statement which is taken to be true without proof, which is accepted as true. A statement which is accepted as true without proof. No proof is required. Okay. So that statement is called either postulate or axiom. Okay. A statement or something which is taken or accepted as true is called axiom or postulate. I am giving you one example. If you have studied Dalton's theory, okay, in chemistry, if you have studied, there you have seen that somewhere it is written that all the matters are composed of smallest particles, and those smallest particles are called atoms. This is nothing but postulate. This was accepted by all the scientists at that time without proof. Okay, without proof. None of them examined experimentally whether that statement was correct or wrong at that time. Okay. Later scientists have found that that statement was wrong actually. Now you know that subatomic particles are also there, like electrons, protons, neutrons, etc., etc. Quarks are also there. Okay. So later it was proved that that statement was wrong. But at that time, that statement, smallest particle is the atom, that statement was taken to be or accepted by all the scientists to be true. So that can be considered as an axiom or postulate. So in the study of science, very frequently, we will come across these terms. For the development of this theory, these are the postulates. For the development of this theory, these are the axioms. So like this. Okay. So first two over. Now come to the third point, hypothesis. So plural is hypothesis, singular is hypothesis. Thesis, hypothesis, hypothesis. You have heard Avogadro's hypothesis. I think you know this term, Avogadro's hypothesis. So hypothesis and law. What is the difference? Now I am talking about hypothesis and law. The third and fourth term. What is the difference? You can say that both are same, but actually they are not same. Most often students or the teachers also say that both are same. But if you make an analysis between these two, then you will see that hypothesis and law are not same. Law is well established. Experimentally, it has been verified, and not single time. Many times by many scientists, the law has been verified. If it is not verified, then that thing cannot be called as, cannot be termed as law. Okay, cannot be called as law. Yes, that thing can be at that time. Suppose you have roughly done few experiments, not examined carefully, not examined properly. You have roughly got some idea or mathematical relation between two parameters or between two variables of any experiment. Okay, and you have found a mathematical relation between them. Say the variables are x and y, and you have got y as a function of x. Somehow you have got, but you have not checked it properly. Yes, for few cases you are finding that yes, this mathematical relation holds good. This is valid. Okay, then in that case, since it has still not been verified experimentally with certainty, okay, then at that time that thing can be called as hypothesis, but not law. In the very beginning I have told you that both are regarded as same, hypothesis and law, both are regarded as same. But if you want to differentiate between those two terms, then you will see that law is more established than hypothesis. Means whenever something has already been established properly, carefully, with certainty, okay, then that thing is called law. Otherwise, the same thing will be called as hypothesis. Okay. And law, you know, example of law such as Newton's law of gravitation, Newton's laws of motion. 3 laws are there regarding motion. Those things are called laws of motion. Last term is theories. I have written here. Singular form is theory. Okay. Theory is what? So in case of law, if you talk about now, if you think just about Newton's law of gravitation, there what you have found there, any two objects of this universe are attracting each other, and the force of attraction between them is proportional to the product of their masses. and it is inversely proportional to the square of the distance between them. So that way you have studied Newton's law of gravitation, and the mathematical form is F is equal to g m1 m2 by r square, where r is the distance between them, m1 and m2 are the masses of those two objects, and capital G is there. That capital G is universal gravitation constant. Okay, so this thing you know. But so this mathematical relationship is known among force, masses and distance. Three variables are there: mass, force and distance, and this relationship is known to you. But why and how? If I ask you why those two masses are attracting each other, you won't be able to answer to this question just by studying Newton's law of gravitation. Why those two masses? Why every two masses of this universe are attracting each other? What is the cause of attraction? You won't be able to answer to this question if you study only Newton's law of gravitation. Why there is inverse square law? Why this force of attraction depends upon distance? Why the force of attraction is reduced, decreases? Why the force of attraction decreases when distance between them increases? If I ask these questions, then there will be no answer. Just by studying Newton's law of gravitation, you won't be able to answer to this question. So that's why this mathematical relationship or the statement of the Newton's law of gravitation can be called as law but not theory. Law is well established, there is no doubt. It was proved experimentally that this law is correct. Okay? But theory is more established than law. Now, what is theory? In theory, you will get also such mathematical relationships. And they are established experimentally. They have been verified experimentally. But with these mathematical relationships, verified mathematical relationships, experimentally verified relationships, you will get two more things. Okay? What are those things? You will be able to answer to the question why and how. How things are occurring and why things are occurring. Proper explanations are there. Unless and until you find proper explanation for the happenings of things, up to that, the mathematical relationships, if you have already found, then that will be called as law. And when, along with mathematical relationships, you are able to answer to the question why and how those things are happening, then that will be called as theory. So theory is more established than laws. Theories are more established than laws. Now I think all of you have understood all these 5 terms clearly. Okay? Yes, my aim was to make you understand. My aim of this lecture was to make you understand these 5 terms. You should have clear idea about these 5 terms when you are studying these subjects of science, whether it is biological sciences, whether it is chemistry, whether it is physics or any other science. Okay? All of you should be well aware of these 5 terms. Actually, in the study of science subjects, if you don't have clear idea about each and every term being used in the study, then you won't be able to understand that science properly. You won't be able to understand that science thoroughly. to get clear ideas about the science subjects. Each and every term should be known clearly. Okay. So that way you should study your subjects. Then only there is a chance that you will be able to get an expertise in your field. Okay. Otherwise, it won't be possible. Just getting marks in subjects, say you have got 90% marks or 95% marks, that is not sufficient. That way you cannot say that you know everything of that subject. Okay. Getting marks is another thing. Okay. And knowing the subjects properly, that is other thing. Both are two different things. Okay. Both are two different things. Both are not same. Anyway, I think I have been able to make you understand all these 5 terms clearly. And still, if you have any confusion, please write me in the comment box. Okay? I must try to answer to your questions. Okay? Thank you. Thank you for watching this video.